Hey, welcome back to Fan Mama Physics. This is part 2 of 5.4, matching equations to graphs. You'll notice that in this diagram here, you might see all sorts of very similar graphs, and they all tend to do one thing. They all tend to cross the origin. If you take a look at this one, it looks like a bunch of x's that touch the origin. And what we're going to do is we're going to again do some matching. This video is just going over the bare bones, pretty much generating some values and seeing if these values, which are the coordinates on the graph, whether these coordinates fit certain graphs versus other ones to identify which equation matches to which graph. Okay, so we are going to start right now. Okay, we're going to do the first one together method. So here are our equations 1, 2, and 3, and our graphs A, B, and C in those different colors. So I am going to do, well, if I do 1 and 2, then you'll know exactly which one is 3. So maybe what I will do is I will do number 1. And I want you to do number 2. And we'll come back together to do number 3. Okay? So for number 1, okay, we have y is equal to x. So let's generate some coordinates here. For example, we probably shouldn't use 0, 0 because all 3 graphs cross the origin at 0, 0. There's no point in doing that. So might as well use 1. If x is 1, then y must also be 1. Hey, because they're equal. Next one, if x is 2, then y must also be 2. Okay, take a look at the pattern. Notice that they all increase by the same amount sideways as well as upwards and downwards. Okay, so it just keeps going like that. Let's take a look at the graph and which one represents this one the most. So let's take a look at 1. If I have a value of 1, I should get a y value of 1 as well. So hey, it's looks like it's graph C, but let's confirm again. If I have x is equal to 2, my y is 2. Okay, then it's 3, and it's y is 3. If I have 4, then my y is also 4. It kind of goes up by this constant rate. So we know that the first one is C, graph C, okay? This is an interesting concept because notice that as I increase my x by 1, my y also increases by the same amount. So I go over by 1, I go up by 1. Go over by 1, go up by 1. So it's like the same increase. It's a constant change. Okay, so that's the interesting thing about these graphs. They all talk about constant change. So what about number 2? Okay, give number 2 a try. All right, so again, you're just generating some values. So hopefully it shouldn't have been too bad. This time you have 2x. Okay, so then if I put x is equal to 1, hey, that means my y is going to be 2. If I use x is 2, my y is going to be 4. Okay, so every time it is increasing by 2 and not 1. So that's interesting. Okay, I'm going to use these values. I think that's enough because if I take a look at the graph, I go 1 for my y. Sorry, for my x. My y is now 2. Looks like graph A, but let's keep going. If I have 2, then I go up by 4. Okay, and voila. So then this looks like it's graph A. Now this is in contrast to graph C. Notice my graph A is steeper, and notice that the difference between the equation was that I have a larger coefficient in front of my x value. So somehow having a number in front of my x value gives me a steeper slope. If you know the slope y-intercept form of the equation, you know exactly why it is the way that you see it. But let's say you don't. And if you don't know that, you can kind of see the pattern here with the coefficient in front of the x. Every time my x goes up by 1, my y is going to go up even higher depending on what this number in front of the x is. So it's like the idea of the slope. Haha, we're kind of merging us together in terms of people who know about the slope y-intercept and who might not know so well about the slope y-intercept. Okay, so that is an interesting pattern to keep note of. If I had to draw this pattern, take a look at this. I go over by 1, up by 2, over by 1, up by 2, over by 1, up by 2. So that's kind of what the 2 is. 2 is almost telling me how high up I'm going every time I'm increasing my x by 1. Very interesting stuff. Okay, so we have one more, and you know by default it must be graph B. But let's take a look at why it is graph B. Generating some values, I put in 1, but if I put in 1, I'm going to get -3 for my y, okay? Again, if I put in 2, 2 times -3 is going to give me -6. Okay, what do I put in 3? I put 3 in, 3 times -3 is going to give me -9. So notice that negative sign makes all of my y values flip to the other sign. So that means if I had a negative x value, negative times negative is going to give me a positive y. So this negative number here in front of my 3 almost flips the my y values to the other side, given my x value. And because there's a 3 in front, it's every time I go over by 1, I increase the y by 3 more points, 3 more units. Well, it's going down by 3 more units because it's negative. But you kind of get the idea. The increase is now bigger compared to before when I had a coefficient of 2. So what does that mean on this graph here? So for graph B, let's take a look. If I go over by 1, I should get -3, which is right there. If I go over by 2, I should get -6. And then it should go all the way down here, which is -9. But let's say I use -1 instead. -1 times -3, that's going to be +3. So that's going to be right over here, okay? Now, what that looks like is, if I go over by 1, I drop down by 3 values, 1, 2, 3. So the dropping is it kind of means it's represented by the negative value, and then the amount that I drop by is equivalent to the coefficient that is beside my x variable. I go over by 1, drop by 3. Go over 1 by 1, drop by 3. Go over by 1, drop by 3. I'm probably going to end up down there. Okay? So it's almost so the coefficient in front of the x not only tells me the steepness of my slope, but it also tells me whether my slope is sloping upwards or sloping downwards. Sloping upwards give me positive I have a positive value in front of my coefficient. Negative means negative slope or sloping downwards, like downhill. And the larger my number, the steeper my slope is. Very interesting. And that kind of touches on method 2 already. Graphs also show pattern relationships between x and y. For each graph, determine the pattern relationship between x and y. Here, we can just type this one out, and I just mentioned this already. So for example, here, as x increases by 1, y increases by the same amount. So notice that we're trying to describe the pattern instead of just using math symbols and graphs to do that. So for the second one, as x increases by 1, my y increases by 2. And last but not least, the last one, as my x increases by 1, my y not increases but decreases by 3. So the negative sign kind of is represented by the negative sign increasing. Oh shoot, that should say decrease, my bad. The negative sign tells you if it's increasing or decreasing, and then the number tells you how much you're increasing or decreasing by. Okay, that's the idea of a slope. Okay, so we have one quick one here. We have which graph on this grid has the equation at y is equal to 3x minus 4. To identify the appropriate graph, pick 2 points on each graph and check to see if their coordinates satisfy the equation. So that is kind of the other way you could do it, because before we've gone from the equation to the graph, now we're going from, okay, let's go to the graph and see whether or not these points on the graph satisfy the equation. So that's another way to figure out the match here. So I'm just going to do that quickly. For example, for graph A, and I'm going to change them because on the graph it says 1, Roman numeral for 1, Roman numeral for 2, Roman numeral for 3. For graph 1, for example, there's a point there which is 0, 2, which my x is 0, my y is 2. For my graph B, my 2, I have it intersecting the origin there, which is really cool. And then my graph C, which is 3, it intersects very nicely here at 0 and -4. Okay, so let's put in each one of these into our equation to see if it matches. So if I put x is equal to 0, I get y is equal to, well, that's 0, so I just get y is equal to negative 4. So that can't be graph A, okay? What about graph B? If I put 0 in there, I get y is equal to, again, negative 4, which doesn't work. So that doesn't work, cannot be graph B. Well, by default, it should be graph C, but let's see y. So if I put 0 in, oh, hey, it does work here because I do y is equal to 3 times 0 minus 4. I get y is equal to negative 4. And negative 4 matches our coordinates there. 0, negative 4. And therefore, graph 3 is our answer here. Or graph C, if you're following by this format. Okay? So that's another way how to match your graph. You could go from your graph to the equation or from the equation to the graph. Whichever way works the best for you. Okay? Alright, so this is our lesson for today. And also, I will be doing another version of this particular half of the lesson, which I will use the slope y-intercept method to show you how all this works. So, hopefully, I'm going to zoom out. Hopefully, this video was helpful to show you the relationships of an equation relative to a graph. See you next time here to talk about slope and y-intercept form. Thank you for watching. Fat Mama Physics signing out.